Okay, today we are going to discuss first an important question related to transformer, like transformer rating. In transformer rating, we say about voltage rating, that is rated voltage, current rating. We don't say normally voltage rating, temperature rise, and one important thing is kVA rating. And now question is that for many other electrical equipment we say kilowatt rating or in wattage rating, but in case of transformer why kVA? So the question is why transformer rating is in kVA? Why transformer rating is in kVA, that is kilovolt ampere? Why not in watt or kilowatt? So to answer this question, in case of ideal transformer, we know that there are no losses. That is, the input side power is equal to the output side power. But in case of practical transformer, in the last video is transformer. In the last video, we have seen that there are multiple losses, like the winding losses or copper losses occur in the primary and secondary winding. That is, these are the I square R losses. I1 square R in the primary side and I2 square R in the secondary side. These are the copper losses. And similarly, iron or core losses are there. Iron or core losses that occur in the iron core, namely hysteresis loss and eddy current loss, already discussed in the last video, eddy current loss. So these losses and leakage reactance, this makes and transformer makes a practical transformer different from an ideal transformer. And this is the same reason basically this copper loss is dependent on this I square R, that is I1 square R or I2 square R. The copper loss is dependent on the current. Which current? Basically load current. But primary current is dependent on load current. If load increases, then primary current increases. To maintain the flux, again the primary current has to increase. So basically we see that these losses are dependent on, let's say copper losses are depends on the current or load current, we say. Similarly, the iron or core losses, that actually depends on the maximum flux density Bm. That again depends on the primary current, that depends on the primary voltage or supply voltage. So in other words, we can write this iron or core loss depends on the voltage. So effectively, again we know this kVA, and what is the relation between kVA and wattage? Kilowatt. This kilowatt is nothing but kVA into load power factor, cos phi. This load power factor, what is load power factor? This is the cos phi, and this phi is actually phase angle between load voltage. Load voltage means secondary terminal voltage and load current. Now we see this whole loss doesn't depend on power factor, it only depends on voltage and current. So if we say the rating in terms of volt into ampere, that is volt ampere, and in kilovolt ampere, that is kVA, then we have no problem, because the output doesn't depend on the losses doesn't depend on the load power factor, but actual wattage for the same transformer, actual wattage may vary, because due to different connection of different load, the load may be inductive, power factor may change, may be resistive. So depending on the load power factor, our kilowatt rating will change for the same transformer. So if we rate the transformer based on kilowatt rating, then that will be variable for a particular load. That is something, and if we change the load for the same transformer, then the rating will be changing. So we write in terms of kVA, so that only it doesn't change with the change in load or load power factor. So for an example, we can say, like, in other words, that if we say a 100 kVA transformer will have, okay, also the temperature rise in the core due to these losses, that is also the temperature rise will be also the proportional to the apparent power, that is the flowing through the winding or through the whole core of the transformer. So in other words, we can say that a 100 kVA transformer will have same effect, same temperature effect, or same temperature rise with either a 100 kilowatt resistive load, that is unit power factor, or with 100 kVAR inductive load. Suppose this is, we are telling, a pure inductive load, pure inductor. So pure inductive load, that in that case there will be only a totally kVAR, no kilowatt, but the temperature rise will be same. So we see that the losses doesn't depend on the power factor. Power factor becomes 1 in case of resistive load, the same temperature rise. Again, power factor, if for inductive load, power factor is lag power factor. Again, for that also we are having same temperature rise. So essentially the losses doesn't depend on the power factor, and that is the reason the transformer rating is given in kVA. Okay, so next we will move to the very basic we left, we should have discussed very initially, but that is actually very easy part, and students can learn from any book, but we will